Hello to all students who are preparing for the next upcoming set exam. So I am making a series where I am solving all the 100 questions of 26 WB set. So in this video I have put only 10 questions. So this is mathematical science, this is X booklet, and I have solved in this video, I have solved total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. And in the next video I will do from 11 to 20, like that I'll be making total 10 videos for this. So carefully how I've solved it. Any problem you can ask me, you can in the comment box. I know that I have used very traditional method of book and copy to solve this problem, in which I was comfortable. I have not used any smart board or computer because I am not very comfortable with that. I am comfortable in solving on a copy. So I have used the traditional method. So please bear with me and hope you understand what I have taught. So let's start. Given a system of linear equations ax equals to b, if xb is one of the basic solutions for the given basis b, then a xb equals to the other four options. The solution, see what is happening here. A is the coefficient matrix, okay, x is the column vector of variables and b is the column vector of constant. So we all know this standard matrix equation, this one. B is our matrix and xb is the solution, is equals to b. So we'll multiply b inverse on both sides. So b inverse into b will give me identity. So xb is b inverse b. So C is the correct option. This question number 2. If 2x minus x square plus ay square, this is our question, is a harmonic function, then the value of a is 1, 2, 3 or 0. So let's just look at the solution. A function is harmonic if it satisfies the Laplace equation. We all know this. What is the Laplace equation? Del square u del x square plus del square u del square y equals to 0. So our function uxy is given as 2x minus x square plus ay square. So now let us differentiate here. Del u by del x will give me 2 minus 2x and del square u by del x square will give me minus 2. Del u by del y will give 2ay and del square u by del y square is 2a. Now we'll apply this formula. We'll add del square u, this plus this, will add it up here. So we have here minus 2 plus 2 equals to 0, 2 equals to 2 and a equals to 1. So first answer is our correct answer. Now we'll be solving problem number 3. This is a problem of complex integration. So the question is, I is equal integral over contour c z to the power 4 e to the power 1 by z dz, where c is given by mod z equals to 4. So this represents a circle. Okay, so this is a circle of radius 4. So this is our radius 4 circle. So what will be the value of the integral? This is what we have to find out. So the function fz equals to z to the power 4 e to the power 1 by z is analytic inside and on C, except possibility where we have z equals to 0. So whenever z will be equals to 0, there we'll get a singularity. So e to the power 1 by z has an essential singularity at z equals to 0. We need to check whether the Lorentz series expansion contains any 1 by z. So we know that what is the expansion of e to the power x. E to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial. We know the expansion. So we replace x by 1 by z. With instead of x we write 1 by z and we do the same expansion. So e to the power 1 by z is 1 plus 1 by z plus 1 by 2 factorial 1 by z whole square plus. So like this we will do the expansion. Now in our function we have z to the power 4 is multiplied with e to the power 1 by z. So we multiply z to the power 4 here, e to the power 1 by z, we get the first term z4, then z cube, then z square by 2 factorial, then next z by 6, 1 by 24, because in this the z4 term cancels out, and then finally we have this 1 by z by 5 factorial, so 120, 1 by 120z. So by residue theorem, what do we have? Only the coefficient of 1 by z contributes to the integral. So I equals to, this is by the residue theorem, 2 pi I into 1 by 120, which is pi I by 60. So D is the correct option. I hope you have understood this question. So let's move on to the next question now. Question number 4. So question is, let beta is equal e to the raised to the power I pi by 2 and let the matrix M, this is the given matrix, then the trace of I plus M square, this is our trace, is 8 plus I, 8 plus 2I, 4 plus I. These are the four options. So let us go to the solution. Okay, so see, this is a shortcut method which I have used. I have done it by two ways. One is a shortcut and one is a long cut. So by the shortcut method, we know that trace is the sum of the eigenvalues. Okay, so sum of the eigenvalues. So trace of I is very simple. The diagonal elements we add up, we'll get the trace 1 plus 1 plus 1, we get the trace 3. The trace of M, as M is an upper triangular matrix, you can see that M is an upper triangular matrix. You can see here, this is an upper triangular matrix where the lower these elements are 0. So this is an upper triangular matrix. So whenever we have an upper triangular matrix, its eigenvalues are simply the diagonal elements. So the eigenvalues are these diagonal elements only will become the eigenvalues. So if we add these three eigenvalues, we will get the trace. Okay. So trace is 1 plus beta square. So eigenvalues of M are 1, beta and beta square. Then eigenvalues of M square are 1 square, beta square and beta square square. This is a property of matrices that if the eigenvalues of any matrix are M is 1 beta and beta square, then if we have to square the matrices, then we can directly square the eigenvalues. This is a property that if any eigenvalues of any matrix are known, then M square, for M square we'll have to just take the square of the eigenvalues of M. We don't have to solve it. Now solve for beta and beta squares. Let us solve for beta and beta square. So what is beta? Beta is e to the power iota pi by 2. So if you expand this, this will become cos pi by 2 plus iota sin pi by 2. Cos pi by 2 is 0 and iota sin pi by 2 is I. So its value will be iota. What will be beta square? This is iota square, or you can solve it in the long process, or directly you can do iota square, which is minus 1. E to the power I pi by 2 whole square. So 2 and 2 will get cancelled. E to the power pi I, which is cos pi plus I sin pi, which is minus 1. Or you can directly do iota square. Now trace of M is 1 plus beta square. So 1 plus beta is our iota and beta square is minus 1. So 1 and minus 1 will cancel each other. We'll get only iota. Trace of M square is 1 plus beta square plus beta to the power 4. 1 plus beta square means beta square is our minus 1 and beta 4 is iota to the power 4, which is again 1. So trace of I 3 plus M square is 3. The trace of I identity is 3. Trace of M is iota, we can see from here, and trace of M square is 1. So we'll get 4 plus iota. Option D is the correct option. Alternatively, you can go for the long process. For the long process you calculate M square first. So if you multiply M square, then also you will get this only. You can see here 1 beta square and beta 4, and then the same process like this. Trace of 1 plus M square is 3 plus 1 plus beta square. Here the trace of M, this is the trace of M, this is the trace of M square. So again same thing, 3 plus iota, this will be 4 plus iota. But I suggest this will be in the competitive exam, it takes a long time to compute this B square. So it's directly use the property of matrices that if eigenvalues of one matrix is known to us, we can calculate the eigenvalues of M square, M cube by straight away taking the cube or the square whenever. So this is the property. This property we will apply here to save our time. Now we'll move on to question number 5. Which of the following statement is true? Set of singularities of a complex valued function can be countable. Limit z approaches 0, e to the power minus 1 by z square exists. The domain of an analytic function need not be open. And the last one is if uxy and vxy are real differential functions and fz equals to uxy plus ivxy is also differentiable. Now let us look at the solutions. Okay. So solution number A. The set of singularities occur when the function is not analytic. Okay. By Lindelof theorem, it states that the set of singularities of a meromorphic function in a given region is at most countable. Okay. So I repeat again. It states that the set of singularities of a meromorphic function, the function has to be meromorphic, in a given region is at most countable. However, a general complex valued function which is not necessarily meromorphic can have an uncountable set of singularities. So this is in any book you can see Lindelof theorem states that the set of singularities of a meromorphic function in a given region is at most countable. However, a general complex valued function not necessarily meromorphic can have an uncountable, this is important, set of singularities. Now suppose let us consider a function fz equals to summation x belongs to s 1 by z minus x, and suppose our S is the Cantor set. S is our Cantor set. Okay, then we can say this is uncountable. So consider a function that has singularities at all points of the Cantor set on C. Cantor set is uncountable, so the singularities form an uncountable set. So option A will be our true option. Okay. So option A is true. So set of singularities of a complex values function can be uncountable. This will be our true option. Now B, C, D will be false. So let us see how B, C, D is false. So see number B, limit z approaches 0 e minus 1 by z square exists. So this is not right because this is equals to infinity. Okay. So see here, option number B, limit z approaches 0, this one, e to the power minus 1 by z square approaches infinity. So this option B is our false option. Now option number C, the domain of an analytic function is always open because analytic functions are defined on open sets when they are holomorphic. Therefore a function can be analytic on an open subset of C, but if a set is not open, if a subset is not open, see this, if a subset is not open, it cannot be the domain of an analytic function in the usual sense. Thus C is false, because see what is given in C in our question. In C we have the domain of an analytic function can not be open, need not be open. So no, this is not correct. It has to be open. And the last, if ux and vxy are real differentiable functions, then fz equals to this is also differentiable. This is not true. Okay, so see here what I have written. If uxy and vxy are only differentiable but do not satisfy Cauchy-Riemann equation, so there is an additional condition that they should satisfy this Cauchy-Riemann equation, then only we can say that fz is complex differentiable. So real differentiability does not guarantee complex differentiability. Only if they satisfy the Cauchy-Riemann equation, then we can say they are differentiable in the complex plane. So option D is also our false option. Okay. If you have watched till here and you are liking my videos and understanding what I am teaching, I request you all to like, subscribe and comment so that I get motivated to make more videos. So now let's move to the next one, question number 6. So this is a question, the mean curvature of the surface Ez cos x equals to cos y is 0, 1, 2, minus 1. So how do we go about this question? See. So first we'll express it in the explicit form. Ez equals to cos y by cos x. We'll bring the cos x down. Now taking log on both sides, log e to the power z equals to log cos y by cos x. Now we know log e to the power z is z. This is equals to log cos y minus log cos x. Now our z is equals to a function of fxy, which is equals to log cos y minus log cos x. Now we'll calculate the first order partial derivative. So zx is our tan x. You can do this derivative 1 by minus 1 by cos x into d by dx of cos x, and z with respect to y will be minus tan y. Now we'll take the second order partial derivative, zxx double derivative sec square x, zyy is minus sec square y, and zxy equals to 0. Now we'll use the mean curvature formula. You have to learn the mean curvature formula. H is equal 1 plus zy square into zxx minus 2 zx zy zxy plus 1 plus zx square into zyy whole divided by 2 1 plus zx square plus zy square to the power 3 by 2. Now let us substitute the values here. So zy, what is our value of zy? Zy is our tan y. So we'll replace here 1 plus tan square y into zxx. What is zxx? Sec square x. So sec square x minus here zxy term is 0. So zxy is 0, the whole thing will become here 0. plus 1 plus tan square x into minus sec square y. Now 1 plus tan square y is sec square y. 1 plus tan square y is our sec square y. So we will replace here into sec square x minus 1 plus tan square x is sec square x. So the numerator becomes 0, then the entire term will become 0. Okay. Correct answer here is option number A, answer 0. Let's move to the next question, question number 7. So this is a direct formula. This question answer is direct formula. This is for differential geometry. We have the formula that relates the curvature of an oblique section K and the normal section curvature is Kn equals to K cos theta. So this is a directly formula based question. If you have read differential geometry, you will see that this is one of the formulas in differential geometry which relates the curvature of an oblique section to the curvature of the normal section. Okay. A very simple direct formula based question has come. Now let's move on to the next question number 8. Okay. So consider the equation dy by dt equals 1 plus f square t yt. Initial condition y0 equals to 1, t greater than equals to 0. So these are the 4 options. Now let us go to the solution. So this is a separable differential equation dy. We can bring the y down. Okay. So this y we can bring down and dt we can take up. So we can separate it in terms of y and t. Okay. And then we have dy by y equals to 1 plus f square t dt. Integrating both sides, we'll integrate both sides. So here we get log y equals to integral 1 plus f square t dt. Taking the exponents on both sides, yt is equal e to the power integral 1 plus f square t dt. Now we'll apply the initial condition y0 equals to 1. Then we'll get here yt equals e to the power integral 0 to t 1 plus y square f square s ds. Now let us analyze the behavior. So once our integration is done, we have solved the problem. Then we will go for the analyzation of the behavior. We'll analyze the behavior of yt as t approaches infinity. Now ft is bounded. It is given in the question that ft is bounded. Okay. So you can see ft is bounded and continuous function on 0 to infinity. Then we can write that ft is less than or equal to some m. Then ft is bounded implies f square t is also bounded. So 1 plus f square t is greater than or equals to 1 because f square t is a positive quantity. Because the square of anything is positive, so 1 plus f square t is greater than or equals to 1. The integral 0 to t 1 plus f square ds grows infinitely because this is increasing. So this also increases. So therefore yt approaches infinity as t approaches infinity. Now let us look at the options. Okay. The first option says that limit yt is finite. So we can see this is not finite. Yt approaches infinity. So our first option is wrong. The second option is we are getting Li solutions. No, we are not getting Li solutions. Third option says we have a bounded solution. But we can see that it is not bounded. You can see it is going to infinity. Yt is going to infinity. So our third option is also incorrect. And the fourth option says that the solution is unique and limit yt approaches infinity as t approaches. So the fourth option is correct. So according to this, our fourth option will be the correct option. Question 9 is a question on Green's function. Let gx be a Green's function of the boundary value problem is given to us 1 plus x u dash whole dash plus sin x u equals to 0. X belongs to 0 comma 1 close interval and we are given this boundary conditions u0 equals to u1 equals to 0. Then the function gx defined by gx equals to gx comma half x belongs to close interval 0 comma 1 is continuous, discontinuous, differentiable, does not have a left derivative at x equals to 1 by 2. So now let us look at the solution. For a second order self-adjoint operator, so this is a second order self-adjoint operator with separated boundary conditions. So we can see the boundary conditions are separated. The corresponding Green's function has the following properties. So this question can be done by only using the properties. The continuity. The Green's function itself is continuous in x for every y. So this directly by this we can say our first option is correct. Since gxy is continuous in x for each fixed y and its only singular behavior is in the derivative at x equals to y, here it shows singular behavior. but one-sided limit gx comma x plus 0 and gx x minus 0 exist and are equal. The average gx is also continuous. So there is no special value x equals to half where the averaging failed to produce a continuous function. So we do not, it's discontinuous at x equals to half will be wrong. Does not have a left x will be wrong, and is differentiable. In most cases these are differentiable, but we need some additional conditions to show differentiability. So since only one option is correct, so if it is differentiable it will be two continuous also. So we cannot have two correct options, we will have only one correct option. So we know that every differentiable function is continuous, so we'll go for the continuous. This is the best option, continuous is the best option. Now we come to the last question of this video, question number 10. A spring is stretched by applying a load to its free end. The strain produced in the spring is volumetric, shear but not longitudinal, longitudinal and shear, and longitudinal but not shear. So we are given a helical spring. So whenever we are given a helical spring, so this is our spring, it is helical, okay. So it is helical and it is made up of coiled wire. When we apply a load at its free end, here we'll apply a load, so it will get stretched in a longitudinal direction. Obviously it will stretch downwards, producing a longitudinal strain. But because the wire is curved, the load causes bending and twisting on each coil. So each coil will experience a bending and twisting. This leads to shear strain in the cross section of the wire. So option C will be the correct option.